Station, this is Houston. Are you ready for the event?
Houston Station, I'm ready for the event.
Erasmus Center, this is Mission Control Houston. Please call station for voice check.
Station, this is ESA moderator Melanie Cowan. How do you hear me?
Good afternoon, Melanie. I read you loud and clear.
Well, good afternoon, Luca. You are now connected with Israel, Germany, and Italy. Could you please give them a short summary of your mission and ATV, and then open up the floor to their questions?
Well, buongiorno, guten Abend, shalom. Welcome on board the International Space Station. This is the module Columbus. My name is Luca Parmitano, and I'm really glad to have the opportunity to have this wonderful public today here on board the space station. It's an honor. One thing about my mission is that it shares with all the other missions the three main purposes of our space flight, which is it's science, it's technology, and exploration. And very quickly, I can give you a couple of examples of how we accomplished those three important elements of our research. For science, well, you can tell that right now on my forehead, I have a sensor that's been reading my temperature for the past 36 hours, and it will go on for another 24 hours. And what we're doing with this experiment, one of 150 experiments that are going on right now on the space station, it's called circadian rhythms, and we're trying to figure out how living on a space station influences our circadian rhythms. Again, this is a European experiment, and it's one of about 20 European experiments right now on board, and these 20 are part of about 150 that on average every increment belong to come up on a space station. For technology, well, we do technology every day. Just living here on the space station, we develop new technology that can be used on the ground, new softwares. Even coming up on a Soyuz uses new technology every single time in order to improve the quality of the flight and the capabilities, and also reduce the risks. And for exploration, I think that this is sometimes hard to comprehend, that what we do here on the space station is exploration. But if you think that our steps today are paving the way to the exploration of the future, this is a very important time for our future exploration, for space exploration, because what we do today will open the doors to be able to go to other worlds on a different day in the future. Now, part of this exploration is also thanks to the fact that we have constant resupply from Earth. And I would like to say that the flagship of the fleet of cargo ship that come from Earth to the space station is ATV. And the reason why I say it's the flagship is because we have three agencies that provide cargoes. One is the JAXA with the HTV, Roscosmos with Progress, and then we have two commercial spacecraft. I recently captured the second one. The first one is Dragon, the second one is Cygnus. But ATV is bigger than any of them, and it has one special characteristic, that it docks completely automatic, and it really reduces the amount of work and preparation needed by the human interface, which is good when you think that 2.5 years are spent for training to come on the space station, and really capturing ATV, assisting the capture ATV is very, very simple. So it carries, ATV carries fuel, food, supplies, experiments, air, water, really anything you can come up with can be put in ATV. So it's really a fantastic machine, and I was very privileged and very happy to have it on board for the past 5 months. And now that I've shown you that I really am in space by letting ATV float from one side to the other, I'm open for questions if you have any.
Thank you, Luca. We'd like to call upon Israel. Israel, your first question, please.
Hey, Luca. Hey, Luca. My question is, how do the five senses change in space?
Shalom, welcome on board. That's a very good question, and it's part of the ongoing investigations that we do constantly on the space station. There are some of the senses do not change. So, for example, the tactile sensations are exactly the same. We haven't had, I personally, or most people don't have any changing in hearing because most of the time we do wear hearing protection. For taste, I've heard a lot of people saying that because of the fluid shift, our taste changes in that we don't feel the salt as much. So some people like to eat a little spicier here on board the station. I know that my colleague Karen, she likes the spicier food while she's up here. I personally eat very bland food even when I'm on the ground, so I haven't had any need to do that. Now, one of the senses that certainly has a lot of effect on us is the sight, and there is a study ongoing right now, of which I am part, to study how the eyesight is affected by microgravity because of difference in pressure in the bulb. So if you imagine that the ocular bulb is affected by pressure on the ground, well, when you come up here on the space station, gravity is also part of the pressure in that it changes the application point. When that changes, also the eye shape may change, and also the fluid shift may affect that. So there are ongoing studies on how that affects astronauts, either temporarily or permanently, and that is certainly one of the most important. The last one would be smell. I don't think it changes. I noticed that when we get very used right away to the different smells on board the station, we get saturated. And when new cargo arrives, maybe with even ATV with apples or fresh fruit, the smell really is an enticing, is enticing, as intriguing as it is on the ground. It's wonderful to have those.
Thank you, Luca. Germany, we'd like to have your first question, please.
Hello, Luca. Thanks for having me. My question is, would you like to have a robot as a colleague on the station? And in what ways could such a robot be especially helpful in your work?
Good Abend and welcome on board. That's a great question. We do have a robot on board. We have a couple. We have Robonaut, which is a prototype of a humanoid robot to help us in our work on the space station. And then we have two robot manipulators, two robotic arms that we use to help us work. So the answer to your question is, in a way, already we have robotic features with which we interface constantly. I was on top of the Canadarm2 while Karen was flying the arm during my EVA, and also a couple of weeks ago, only 2 weeks ago, I used the robotic the Canadarm, the robotic arm, to capture a Cygnus, and before me, Karen captured HTV. So we already have the use of powerful robotic instrument to help us here on the space station. Now, Robonaut is a great experiment, very cool, because it's trying to figure out how a humanoid robot can help us doing an EVA, eventually maybe taking our place. Well, the study is still ongoing. I think that in the future we will have a lot of interface with our robotic friends, and a lot of people think that maybe they will replace us. That's not true. We will just interface more, interact more, and we will be more integrated as a crew. I hope that answered the question.
Thank you, Luca. I'd now like to call upon Italy. Italy, your question, please.
Is the human role during the docking maneuver fundamental, or are we ready for autonomous assembly in orbit? Thank you.
Well, that's benvenuto a bordo. There is a great question. Are we ready for autonomous assembly? Well, in a way, we part of the space station was built in an autonomous mode. If you remember, the first part of the space station, Zarya, came up by itself, and then Node 1 was attached to Zarya, which is called mostly known by FGB, and then the SM arrived and assembled autonomously. So we have done autonomous operations. The next part of the space station, which will be assembled autonomously, is called MLM, a new research module on the Russian segment. So in a way, I think we are moving towards, we have had that experience, and we moved into a different direction where we assembled the space station on orbit. I don't know what the future will bring. It's going to be, it will be interesting to see what will be the next phase of assembling in space. But I think that the experience has shown that we can do both. And in a way, that is the best lesson learned, is that there are advantages to one and advantages to the other, and we can probably pick the options according to what is most necessary at the future in the future when we build our next either our next spacecraft, our next station, our next orbiting point, and only the future will tell what we're capable of doing. But the answer to your question is yes. I think we can do that already. Over.
Thank you very much, Luca. We'd now like to go back to Israel. Israel, your next question, please.
Hi, Luca. My question is, what was the biggest challenge you have experienced during your time in space, and did you expect the challenge?
Wow. Great question. Great question. It's hard to answer because I like challenges, and so sometimes I don't see them. I don't see them as a problem, as a challenge. I see them as something really cool that I really want to do. Certainly, I think that probably the things that give us most satisfactions are also the most challenging, and for me that would be probably going through the training to qualify as a left-seater on the Soyuz spacecraft. It was very challenging. There were a lot of exams that I had to go through. It took me the better part of 2 years to qualify, and then getting on the rocket and being launched was a fantastic experience, but certainly very challenging. But maybe if I had to pick one that would summarize the pickable challenges here on the space station, I think that my EVA, not necessarily the one with the emergency, but with the inconvenient, but just in general an EVA, when you put it in terms of amount of work and amount of preparation that you need in order to do an EVA, I think that would be probably the biggest and strongest challenge. And was I expecting it? I think I was. I spent over 120 hours underwater on Earth preparing for the EVA, and pretty much the same amount of hours in a simulator training to become the left-seater on the Soyuz. So I think that yes, I expected it to be a challenge. I wanted it to be a challenge, and I think I was ready and prepared for it. Over to you.
Thank you, Luca. We now go back to Germany. Germany, your next question, please.
So hello, Luca. So my question is, what is for you the most impressive thing about the ISS?
Okay, can you say that again? I know that you said something about the ISS, but I didn't quite catch.
Yeah, what is the most impressive thing about the ISS for you?
Okay, copy. I got it. What is the most impressive thing? Well, let me tell you. The ISS just the fact that it's such an incredibly sized spacecraft is incredibly impressive. The sheer size and the thought of the effort of all the humans that had to work in order to assemble this incredibly technological laboratory orbiting around the Earth, I think just the thought is impressive. And right now I'm in Columbus. Straight in front of me, about at least 25 meters away, I see the airlock of the Kibo module. And I know that if I go to my left, this is the direction of flight right now. If I go to my left towards the outside of the space station, I can fly for about 2 minutes slowly, and I'm passing all the different modules. 100 meters far back, we still have space station. It's the ATV module all the way at the back of the space station. It's really, really big, and it flies at 400 kilometers, 28,000 kilometers an hour. If that isn't impressive, I really don't know what else could be impressive. However, if you want something that really, really touched me deeply and maybe changed me as a person, that would be the cupola. When I first opened the windows of cupola on a sunrise, I thought that maybe the world had changed forever for me, because it was an incredibly extraordinary moment. And cupola is European technology, probably one of the most beloved parts of the space station for all the crew members from all the different countries. Over to you.
Thank you, Luca. Our time is getting short. We have just a few minutes left. Italy, your next question, please.
Ciao, Luca. I'd like to ask you, from the station keeping point of view, attitude, depletable checking, power management, and trusted maneuvers, how much of it requires the human intervention, and how much is devoted to onboard automation? And is that performed from the ground?
Ciao, benvenuto a bordo. There is a great question. Well, you guys are you're giving me the greatest questions ever. So, a lot of what you're talking about is that there are different parts. So for attitude, we have 4 huge gyros that keep the station attitude most of the time, and then when they saturate and they cannot control anymore the space station, we have an intervention from the engines to desaturate. Now, that means that the normal orientation of the space station is kept automatically, but then we need human intervention when we need to do specific maneuvers, like a debris avoidance maneuver or a desaturation. Some of those maneuvers actually happen on their own, commanded by the onboard system, like a normal desaturation just happens on its own. But it's always supervised from the ground. For power management, so our solar arrays are fully automatic. They track the sun, they rotate following the sun both in alpha and beta angle, and that's a completely automated work. However, sometimes we need human intervention for specific reasons. For example, when we change the orbit, when we boost, we need to put the wings, the solar arrays, in special configurations so that they are protected. So again, there is a lot of supervision and integration from the ground. So for the power management, also how the systems are performing. Everything, the space station is automated in that it checks constantly what is the status of the space station in terms of safety, in terms of security. But from the ground, they also have the telemetry, and they can pick up a lot of those signals even before the space station can. So to answer your question in few dirty words, the space station is mostly automated. However, we feel a lot more secure, and we have this fuzzy warm feeling because we know that on the ground there are a lot of people that can take over and are watching us and are monitoring us, and they do an excellent job. Over to you.
Thank you so much, Luca. We heard we only have 30 seconds left, so that was the last question. We'd like to give you the chance to say goodbye to everyone in Israel, Germany, and Italy. Thank you for having us on board today.
Thank you so much for coming on board today. It was such a pleasure, such intelligent, good questions from Israel, from Germany, from Italy. Three great countries that cooperate and do fantastic work together. You students are the future. Thank you for coming on board today. Thank you for listening to my answers, and thank you for asking those questions. Thank you very much, and I'll see you next time.
Station, this is Houston ACR. That concludes the event. Thank you.
Thank you, ESA and students. Station, we are now resuming normal audio communications.